Hi guys, welcome to Math. Today, I'll be teaching you how to find the general term Tn of number patterns. I'll be teaching you two general methods that will enable you to find most of the general terms for number patterns in O-levels. Tn represents the nth term in the number pattern, where n is the number of terms. By obtaining the expression of Tn, we are able to predict the value expected at the nth term. For example, we can substitute n equals 4 into Tn to determine the value of fourth term. Let me illustrate in this further using an example. One of the simplest types of number patterns is where the number is increasing or decreasing by a constant value. For example, the number pattern 1, 4, 7, 10, 13, and so on. Here, when n equals 4, the fourth term in the number pattern denoted by T4 is 10. To determine the general term Tn, we first calculate the difference between the terms. We can see that the numbers are increasing by 3 constantly. For this distinctive type of number patterns where the difference between the terms is constant, the general term is in the format of Tn equals An plus b, where a and b are constants to be determined. A corresponds to the difference between the terms, which is positive 3 in this case. Thus, we have Tn equals to 3n plus b. To find b, we can simply sub in any n term. For example, when n is equals to 1, we know that T1 is equals to 1. Thus, we will get the equation 1 equals 3 times 1 plus b. And if we were to solve for b, we will get b equals negative 2. Thus, the general term is Tn equals 3n minus 2. As a good habit, you should always check your answer. You can sub in n equals 5 into the general term you have determined to check if T5 is 13. Let's take a look at another example. Suppose we have this number pattern. We can see the terms are decreasing constantly by 7. As such, a will be equals to negative 7. And right now we have Tn equals negative 7n plus b. When n is equals to 1, T1 is 12. Hence, b is equals to 19 and we have the general term. Tn equals negative 7n plus 19. So we can see that a is basically the difference between two consecutive terms. Do note that this applies only if the difference between any two consecutive terms in the number pattern are the same. Next, we will move on to number patterns that are more complicated where the difference between the terms are no longer the same. Suppose we have this number pattern 5, 8, 13, 20, 29, and so on. First, we calculate the difference between the terms, and we will notice that the difference are not constant. We have plus 3, plus 5, plus 7, plus 9, and so on. However, we can see that the difference is getting larger and larger by 2, which is constant. For such number patterns, the general term is in the format of Tn equals an squared plus bn plus c, where a, b, and c are constants to be determined. To determine the values of the constants, we will have to form three equations since there are three unknowns a, b, and c. First, we sub n equals 1 and t1 equals 5, and we will get 5 equals a plus b plus c, and we label it as equation 1. Next, we sub n equals 2 and t2 equals 8, and we will get 8 equals 4a plus 2b plus c, and we label it as equation 2. Lastly, we sub n equals 3 and t3 equals 13, and we will get 13 equals 9a plus 3b plus c, and we label this equation as 3. Although these simultaneous equations look daunting, you can actually use your scientific calculator to solve them. You can learn how by checking out my other video. Nevertheless, we can still solve these simultaneous equations manually using the elimination method. You can use the substitution method as well, but I personally think the elimination method is a faster and simpler method in this case. By subtracting equation 1 from equation 2, we will get 3a plus b equals 3, and we label this as equation 4. Next, we subtract equation 2 from equation 3, and we will get 5a plus b equals 5, and we label this as equation 5. Next, we use equation 5 to minus equation 4, and that should give us 2a equals 2. And finally, we determine a to be equals to 1. The rest becomes much easier. We sub in a equals 1 into equation 4 and we will obtain b as 0. By substituting a equals 1 and b equals 0 into equation 1, we determine c to be 4. Hence, the general term for this number pattern is Tn equals n squared plus 4. Alternatively, we can use this formula to obtain the general term. Similarly, f, d, and e are constants to be determined, where f is the first term in the number pattern, d is the difference between the first two consecutive numbers in the term, and e is the difference of the difference. Let's apply this formula on the same number pattern. In this number pattern, the first term is 5, and hence f is equals to 5. The first difference, which is our d, is positive 3, and the difference of difference is positive 2. Having found all three constants, the last step is to expand and simplify this expression. Finally, we arrive at the same general term expression as the previous method. This method may seem easier, but you will need to remember what each of the constants in the formula represents. As for the previous method, there is no need to solve the simultaneous equations if you know how to solve them using your scientific calculator. Let's try one last example. You may pause the video and try working out the general term on your own. First, you find the difference between each term. We should realize that the decrement is getting larger at a constant of negative 4. Thus, the general term is in the format of Tn equals an squared plus bn plus c. To find the values of a, b, and c, we first sub n equals 1 and t1 equals 72. We will obtain 72 equals a plus b plus c, and we label it as equation 1. Next, we sub n equals 2 and t2 equals 68 to obtain 68 equals 4a plus 2b plus c, which is our equation 2. Lastly, we sub n equals 3 and t3 equals 60 to get 60 equals 9a plus 3b plus c, and this is our equation 3. Similar to the previous example, we will solve these simultaneous equations using the elimination method. We will first subtract equation 1 from equation 2, and we will get 3a plus b equals negative 4, and we label this as equation 4. Next, we subtract equation 2 from equation 3 to get 5a plus b equals negative 8, which is our equation 5. Next, we use equation 5 to minus 4, and we will eventually get a equals negative 2. To find the value of b, we sub a equals negative 2 into equation 4, and we will obtain b equals 2. Lastly, we sub a equals negative 2 and b equals 2 into equation 1, and we will obtain c equals 72. And here we are, we obtain the general term En equals negative 2n squared plus 2n plus 72. Let us practice using the second method using this example. In this number pattern, the first term is 72, which is our f. As for d, d represents the first difference, which is negative 4. Lastly, the difference of the differences between the terms is a constant, which is negative 4, and this is the value of e. After obtaining these constants, we can expand the expression and simplify it. We will eventually arrive at the same expression for the general term. In summary, we've learned that for number patterns with terms that are increasing or decreasing over a constant value, the general term is in the format of Tn equals an plus b, where a is the difference between any two consecutive terms and b can be obtained by substituting a value of n and a respective value of Tn into the equation. We've also learned how to find the general term for number patterns with increments or decrements that are not constant, but with a constant second difference. For such patterns, the general term is in the format of Tn equals an squared plus bn plus c. As there are three unknowns in the equations, we need to craft three equations by substituting n and its respective Tn. You can watch my video on how to solve these simultaneous equations quickly using a calculator. Alternatively, we can use this formula where f is the first term in the number pattern, d is the first difference, and e is the constant difference between the differences of the terms. I hope this lesson will equip you with the means to tackle number patterns with ease.